Hey guys, welcome to our new unit, Unit 7, Differentiation. Today's lesson is the power rule. So I want you to pause the video and try the warm-up using the alternative method. So the warm-up says find the slope of the graph of this function at x equals -1. So using the alternate method, I know my slope is my derivative. So f prime of x would be limit. You could have used difference quotient, doesn't matter. I find this easier or faster. And this is basically, this is what your formula is. I'm going to rewrite it real quick. Your slope or your f prime of x is this. It's f of x minus f of a over x minus a. So f of x is x cubed over 6 minus a cubed over 6 over x minus a. So if I simplify this, what do I get? I can factor out the 1/6, right? So this would be x cubed minus a cubed over x minus a, right? Limit as x approaches a. I'm going to simplify it and then write the limit thing. So this is, my pen's not working. Oh no. This is actually difference of cubes. I'll write it up here. It's x cubed minus a cubed. So it is, you use SOAP, xa, it's x squared, ax, a squared. SOAP, same, opposite, always positive. Oh, I did it backwards. It was minus. Same, opposite, always positive. So this is what it will simplify to. So it'll be 1 over 6 x minus a, and then I'm left with x squared plus ax plus a squared over x minus a. My whole goal was to get rid of this. Now here I am able to by cancelling it. So anytime you use the alternate method, I've said it in the past, we will be doing some kind of factoring. So now what am I left with? I'm going to apply the limit. 1 over 6. Wherever you see x, I'm going to substitute with a plus a times a plus a squared, which would be what? 1 over 6. This would be times 3a squared, which is same thing as a squared over 1/2 a squared, right? Or a squared over 2. So now it's saying that's what your f prime of x is. A squared over 2 or 1/2 a squared, it's the same thing. I want to find f prime of -1. So it's going to be -1 squared over 2, which is just 1/2, right? So now it took us good like 2-3 minutes, I would say, to come up with the answer. But what if we had a shortcut? This is actually one of my favorite lessons to teach. Would you like to see a shortcut? There are several rules of differentiation that will allow us to find the derivatives of functions more efficiently. So there's a shortcut to it. Basically, you can find it in just one step. You can go from here to this in literally one step. So the first rule is the constant rule. The derivative, we've already discussed the terminology. This is the derivative, y prime. These are the most common ones. You'll see f prime of x. These are the most common ones, dy over dx. This means derivative with respect to x of a constant is always 0. Think about it. Isn't derivative a slope? What's the slope of a horizontal line? Isn't m equal to 0? That's the reason why the slope of, or I would say the derivative of a constant function is 0. The power rule, you're going to love this. You really are going to love this. If n is a real number and a is some constant in the function, so it's something like this. Do you agree? A is your leading term, n is your exponent. So the derivative of this function is, what you do is you bring down the exponent and you multiply it by a. So it's going to be an times x to the, I'm just going to put this in parentheses, x to the n minus 1. So what does that mean? I had that question up there. If f of x was x cubed I'm just going to rewrite it as this, or over 6, right? So what did I say? Bring this over, so it's going to be 1 over 6 times 3, which is what? 1/2 x and a degree less, 2. I was able to do the above question in one step, and that's the power rule. So this is your derivative. That's why I said I would love this, and you're going to love it too. Now you don't have to do that whole lengthy, messy work unless the question asks for. Again, you can always use the power rule. So let's get started with our examples. So what is the first one asking? It says find the derivative of each of the following. So we talked about it. The derivative of a number, of a constant, is always 0. We're going to use the power rule here. So g prime of x would be what? You multiply these two. So 3 times 2 is 6. X, 3 minus 1 is 2. And you don't have to show any work. You literally can go from one to the other step. This I would actually, whenever you get radicals, I like to simplify them. This can be rewritten as 1/3 over 3. Or if you want to put the 1/3 in the front, that's even better. So now y prime, or derivative of y, just going to zoom in. So you bring that in the front. Oops. You bring the exponent in the front. So it'll be what? 1/9, right? So 1/9 x, and what's 1/3 minus 1, which is negative 2/3. Now I don't want to leave negative exponents, so what do? I take this whole base or whole part and put it in the denominator. So 1 over 9 x over 2/3, or I can rewrite it as 1 over 9 cube root of x squared. Either or is fine. Okay. The next one, again, I see radicals. I just want to simplify this, and I want to rewrite it as 6 over x to the 3/5. Right? Anytime you have variables in the denominators and you have a quotient up there, can I just shift it because it's easier to simplify? I'm going to rewrite it as h of x equals 6 times x to the negative 3/5. That's okay to do because it's easier to apply the power rule here. Now, what do I do with the exponent? Bring it to the front, so multiply that. So what's 6 times negative 3/5? It is negative 18/5. So h prime of x is negative 18 over 5. And what's negative 3/5? I'm just going to rewrite it so that you can see. Minus 1. Right? Let's write this whole thing together so we understand this better, because there's a lot of stuff going. So I did 6 times negative 3/5 times x, right? And this would simplify to negative 18/5. And what is negative 3/5 minus 1? It is negative 8/5. Right? So I cannot have a negative exponent. I'm going to move it down. So h prime of x is negative 18 over 5 times x to the 8/5. Or I can choose to rewrite it as 5/5 root of x to the 8th, right? So either or is fine. That's how you apply the power rule. Now there's another question. It says find the equation of the tangent line to the graph. So now what you need to do is find the slope, right, and a point. I already know my x coordinate is negative 1. I can find my y. So if I substitute in x for negative 1, I get y equals negative 3. Right? Negative 3 times negative 1 square is just negative 3. So I already have my point. All I need to do is find the slope, which is the derivative. So I already know f prime of x would be what? Apply the power rule. Negative 3 times 2 is negative 6 x to the first. So I want to find the derivative at negative 1. So it'll be what? Negative 6 times negative 1, which is just 6. So you know your slope. It's of the tangent line. Be careful, okay? Not the normal. and you know your point. So I'm going to use my point slope. It's y minus y1, which is y minus -3 would be y plus 3 equals 6 times x minus -3. Oh, -1. X plus 1. So that's your equation of the tangent line. Rule number 3 that we're going to learn today is the sum and difference rules. They're very simple. They're very similar to actually your limit rules also. So you can take the derivative of each one. So I can literally, if I had to find the derivative of this function, it'll be f prime of x plus g prime of x. Similarly for your subtraction also, minus g prime of x. You can take the derivative of each individual part. So here it says find the derivative of each of the following. So basically I can take the derivative of each one separately. I can apply the power rule to each one of them. So f prime of x will be, what's the derivative of x cubed? It will be 3x squared. Derivative of -4x would be just -4, because it'll be 1 minus 1, which would be 0. And a derivative of a constant is just 0. So this is it. 3x squared minus 4. This one here, it would be what? G prime of x. Let me zoom in. So this would be the 4 would come in front. So -4 divided by 2 is just -2x cubed. Plus this would be what? 2 times 3 is 6x. 3 minus 1 is 2. And derivative of -5x is just -5. And that's it, basically. You really didn't have to do anything fancy here. Just do it individually. Simplifying or rewriting becomes extremely important when using the power rule, which I did that for question number 1D. I told you anytime you have radicals, make sure you write it in fraction, the exponents in fractional form, or if you have them, the radicals in the denominator, you can move up and so on, so forth. So here, this one, how do I do this? So here I must simplify it in order to apply the power rule. So I'm going to rewrite y equals, the square tells me I'm writing it out twice. And then if I multiply this whole thing out, I'm going to multiply these two out and then multiply by the x, or I get y equals 9x cubed plus 12x squared plus 4x. And now take the derivative. So y prime would be what? Multiply these two. 9 times 3 is 27, and 3 minus 1 is 2. Plus, this was 12x squared. Yes. So this would be 12 times 2 is 24. X to the first plus 4. So that is your derivative. On this question, I can I not divide each of them by my 2 rad x? I'm going to do that. So what would that be? Oops. So here, h of x, it's still h of x. I'm going to simplify it before. So 2 divided by 2 is just 1, and x cubed divided by rad x is x to the 5/2, right? Then 3 divided by 2 is -3/2, and x squared divided by rad x is x to the 3/2, right? And then I'm left with plus 7 x to the 1/2, right? This is x to the first, and this is same thing as x to the 1/2. So I'm just subtracting the exponents because it's division. Plus, can I rewrite it as 5x to the -1/2? So that's very important to remember. Anytime you're applying the power rule and you have a variable in the denominator by itself, just move it up and make the exponent negative. So now I'm going to take the derivative of each part individually. I'm going to apply power rule 4 times in this question. So I'm going to change colors. H prime of x is equal to, so the first one would be what? bring down the 5 halves. 5 halves minus 1 is what? 3 halves. The next one would be what? Bring this into the front. So 3 halves times 3 halves is 9/4, and 3 halves minus 1 is just a half. Plus, what is the next one? This would be what? 7. Oh, this was 7/2. My bad. I forgot to copy this too. So this would be 7/4. 1 half minus 1 is negative half, right? Minus, this would be what? 5 times negative half is negative 5 halves. That's why I wrote negative 5 halves, and negative half minus 1 is negative 3 halves. You can leave it like that, or I would just simplify. Mostly I would say if your exponents are negative, always make them positive. So 7/4 rad x actually. Oh, let me rewrite it because this looks like 4th root of x. So this is 7/4 rad x, right, minus 5/2 x to the 3 halves. So that's what it would be. So that's your final answer. I want you to finish the remaining problem set. Good luck.